Hello there, children. Today, we are going to work on the review for logs and exponentials. Boom! Explosions! Let us begin. So, all these problems today come from review 3. So this first problem there, I have 16 to the v equals 1 over 64 to the 3v power. Now, I need to make both of these have the same base. So what I do is the following. 16, you can write it as 4 squared, or I'm going to write it as 2 to the what power? Let's think here. Let's think about that for a second. 4th. And 64 is really what? 2 to the 6th. Now, wouldn't it be great if this were on the same level? Why, yes it would. I can flip these, and that should be a v, not a 4 there. So, what I have is to the 4 to the v. I can put these on the same level, because when I flip a fraction, it makes it negative, the exponent. So now, I really have 2 to the 4v equals 2 to the negative 18v. Based on our exponent property, it says if I have the same base, that means my exponents are equal. I have 4v equals negative 18v, and the only way that happens is if v equals 0. So, what I have there, I can add 18v to both sides. I get 22v equals 0, divide by 22v equals 0. And putting that back in here, anything 0 power is 1, 1 equals 1, so I'm good. You should always check your answers. Okay, moving on. Okay, let's go through another sample problem, shall we? Now this problem looks pretty awful, but what I can do here, remember, is I am going to work through this problem by isolating this guy right there, or girl, whatever you want, by isolating it by itself. That means adding 7.8 to both sides. Why am I isolating it, you might ask? Well, I need to get this by itself so I can turn it into a log, because as we can obviously see right now, there is clearly a variable in the exponent that I need to somehow deal with. Now I'm going to divide both sides by negative 8 here, because again, it's not isolated because I have a coefficient there. You cannot, under any circumstances here, multiply negative 8 by that 9 because they are different. Even if they're the same, you really don't want to avoid doing that if at all possible, unless you absolutely have to. But if they are different, you definitely can't do anything with them. Now I get 9 equals 9 to the 9a plus 1.4 equals 11.525. At this point, we do our little loop diagram we've talked about at great length here. This is the base of that equals that. So now I turn it into a log. Now, you fancy calculator folk here, this is where you've got some advantage if your calculator can type this directly in. Otherwise, you're using the good old-fashioned change of base formula, which you all should know and love by now. For those that need a refresher on the change of base, because it's all about that base, no exponents. So what I'm going to do is either use the ln of 11.525 over the ln of 9, or if you're feeling frisky, you can do the log of that. Log of 11.525 over log of 9. So take a minute right now and do that. Now, if your calculator can do this, you're totally okay with that. But otherwise, it's change of base for you. Now, this is where we're going to end up rounding a little bit, so we're going to end up getting this. I'll go up here so everyone can see it a little bit better. Not like it matters, it's a video, but 1.11255 equals 9a plus 1.4. Because if you look back over here, the 9's are way there, so we get this right there. Now, how do I solve for this? Fairly simple. I subtract 1.4 from that. Now, if you round it here, you're going to get slightly different answers than I will. That's totally okay. I'm just typing this all in my calculator as one command line. And then to finish it off, I'm going to divide by 9. And get the following answer. A here is going to equal negative 0.0319. There we go. Oh, happy days, you're here again. Moving on. Next problem. Alright, so this one here. I have log equaling log. Do they have the same base? Yes, they do. And it's all about that base. When they have log equaling log and it's the same base, what I can do then is I can set the insides equal to each other. And solve. That means I'm going to add 2v to both sides. When I add 2v, like I did right here, I get negative v equals 7. Now I'm just going to divide both sides or multiply both sides by a negative 1 to get v without a coefficient there. And I get v equal to negative 7. Now I know what you're saying. I thought I couldn't have negatives. Kind of. You're not allowed to have negatives inside here. But as you see, negative 3 times that negative 7, 21. Yay! 7 minus negative 2 times negative 7, that's 7 plus 14, 21, not a negative. So as long as the insides of my logs, or what are called the arguments, are not negative, we're good. So yes, that is a good solution there. So you need to check your answer, but that is a good solution. Moving on. Next problem. Alright, unfortunately here I've gotten one log. So when I have one log, just like my exponentials, I need to isolate it. How do I do that first here? I'm going to add 7 to both sides. You cannot combine these two together because that negative 7 is attached to a log there. Let's be very clear about that. So then I get negative 7 log base 7 of 10m equals negative 28. Is the log isolated? No, it is not. I've got to divide both sides by a negative 7. Okay. When I do that, I get the following. I get log base 7 of 10m equals 4. Now, what I do from here, I've got the log isolated. I use my little loop again, starting at the base and running around there. So what I get is 7 to the 4th equals 10m. We'll go up here. I know what you're saying. 7 to the 4th. Can I do that in my head? Well, you could if you really wanted to. It's 2,401 equals 10m, or you have a calculator available to you, by the way. And how do I solve for n? Lo and behold, you divide both sides by 10, and there is your final answer. This is fine. I don't need the decimal. So if you gave me this, we're good. We are made in the shade with lemonade, as they say. If you felt the need to give me the decimal for some reason, it's 240.1 equals m. Both answers are acceptable. All right. Moving on. Next up is a very fine problem like this. You need to condense these back to one log. A reminder that what I have right here is really, if you think about it long and hard, is this. Remember, dividing by 3 is same as the multiplying by 1/3. So when I do that, now what do? I take all of my coefficients, throw them up as exponents. That's not too bad at all. Now, that should be a W here. Now, when I throw the coefficients back up as exponents, I can then proceed to my next step. Now, what is my next step? Remember that multiplication is brought back together and spread out by addition, so it works in reverse. If you have addition, you bring that back together with one log only by multiplication. I cannot stress that enough. One log only. And there's your final answer. It is condensed fully. So there you go. Oh, happy days are here again. Alright, next problem on the docket is the following. The log base 3 of that particular item there. Now, what I would do first is, because sharing is caring, I am going to share that exponent with both terms here. When you have a power to a power, you multiply the exponents. Now, remember, that division bar there looks awfully like a subtraction symbol, which is how I split up division with logs. Oh, goody gumdrops. So I do this. Am I done yet? Absolutely, positively not, because I have exponents here, and those exponents need to get dropped down in front, like so. Chop down like trees, using that wonderful, inglorious power property that we've mentioned so many times in class before. So I end up doing this, and I'm good to go. So, oh happy days are here again. Now it is fully expanded, and I'm done. Moving on. Okay, next problem on the docket here. Now, a reminder quickly here is, again, for the umpteenth time, log base 6 z to the 6th x to the 1/3, because I can rewrite this. This is my denominator of my fraction. You've got to know that. So now I split it up using addition. Oh, happy days are here again. But am I done? Most certainly not, because even though I split it up with addition, because that's how I split up multiplication with logs, I still have powers that need to get dropped down in front like coefficients. Now, once I do this, I ask myself, can I spread it out any further? No, I can't. Have I taken all of my exponents and dropped them down as coefficients? Why, yes, I can. So let us bask in the glory of what we have done. And box or circle in my answer. And then I'm good. Oh, wait. Boop. You are now ready to complete the work. Go henceforth and do. Commence.